Welcome to JEE channel. You can practice more problems on this exact topic on our Padhai Kar Lo Android app, link in the description below, or on our website padhaikarlo.com. Today's topic is esterification, the acid-catalyzed reaction between alcohols and carboxylic acids. Let's begin. Esterification is the reaction between an alcohol and a carboxylic acid in the presence of a small amount of concentrated sulfuric acid, or dry hydrogen chloride gas acting as catalyst, to form an ester in water. The mechanism proceeds through nucleophilic acyl substitution. The acid catalyst first protonates the carboxylic acid S-own carbonyl oxygen, making that specific carbon considerably more electrophilic. The alcohol S-oxygen then attacks this activated carbon as a nucleophile, forming a genuinely tetrahedral intermediate, and finally water is eliminated, regenerating the carbonyl group and releasing the catalyst back unchanged. This entire reaction is genuinely reversible and reaches the real chemical equilibrium, which is precisely why an excess or either starting reactant, or actively removing the water byproduct as it forms, is commonly used to deliberately push the equilibrium forward toward greater ester formation. This specific acid-catalyzed ester-forming reaction is genuinely named Fischer esterification, after the chemist who first thoroughly studied it, and a particularly elegant piece of experimental evidence use oxygen-18 isotope labeling confirmed the exact mechanism, when the alcohol S-own oxygen was specifically labeled with the heavier oxygen-18 isotope. That labeled oxygen atom was found afterwards in the resulting ester product, not in the water byproduct. This directly, conclusively proves that it's specifically the carboxylic acid S-own hydroxyl group, not the alcohol's hydroxyl group, that's actually lost as water during the reaction. Pierre Kirkmarkier, paraphila, Philadelphia, Philadophil, Philophone, Philpia, Philodot, Symphony, Philadelphia off. For JEE purposes, recognizing esterification specifically requires spotting both an alcohol and a carboxylic acid or occasionally an acid derivative like an acid chloride or acid anhydride, reacting together under acidic conditions. Acid chlorides and anhydrides genuinely react considerably faster than the parent carboxylic acid itself, since they're inherently more electrophilic at the carbonyl carbon, and these specific reactions don't require acid catalysis or produce genuine equilibrium limitations the way direct acid plus alcohol esterification does. The reverse reaction, ester hydrolysis, breaking an ester back down into its original alcohol and carboxylic acid components, can proceed under either acidic conditions, essentially the exact reverse of esterification, or under basic conditions called saponification, which is genuinely irreversible, since the carboxylic acid product is immediately, permanently converted into its unreactive, deprotonated carboxylate salt form under those specific basic conditions. Let's recap. Esterification combines an alcohol and carboxylic acid under acid catalysis, through nucleophilic acyl substitution, to form an ester and water, in a reversible equilibrium reaction called Fischer esterification. Oxygen-18 labeling proved the carboxylic acid S-own hydroxyl group, not the alcohol S, is lost as water. And the reverse reaction, ester hydrolysis, is reversible under acidic conditions, but irreversible under basic conditions, saponification, which produces the stable carboxylate salt. That's esterification. Keep the oxygen-18 labeling result and the acid versus basic hydrolysis distinction sharp. They're classic JEE conceptual questions. If this video helped, please like it and subscribe to Padhai Kar Lo for more JEE preparation content just like this. See you in the next one.